Working with triggers. What is a trigger? Let's reiterate. It is a coded database event. It is a thing that happens. It is a chunk of code that is executed by a database event, something that happens in the database, such as an insertion into a table, and it says go and execute the trigger when something happens. The event causes the execution. Triggers can be used for referential integrity. It's not a good idea. It's really not recommended. It was listed in the Oracle manuals for years as an option for enforcing primary and foreign key checks and referential cross-checks within a relational database model. It's not a good idea. It's better to use primary key and foreign key constraints and always create individual single-column indexes on each foreign key column. We can use triggers to log events, as in a log file. Within an application, when something happens, you go and create a value into a log file. It actually is more efficient to use something internal to Oracle called Oracle Auditing, but that becomes generic. You don't get to change the descriptions and the way it actually produces information. You want to be careful using triggers because it can produce a lot of overhead in a busy database. So, create trigger syntax again, or replace. You don't change the code, you simply take the code and replace it. If it doesn't exist, you add it. And as you can see, we have various pieces of syntax. This means execute the trigger before an event occurs, after it occurs, or instead of. What does that mean? Well, if you insert into a table, it means, okay, so if I put a trigger that says before I insert into that table, it'll execute the trigger before it executes the insert. Obviously, this means it'll execute the trigger after it executes the insert. And in some cases, you can even tell it to execute the trigger as opposed to execute the DML command, something else. You can have any combination of insert, update, and delete before, after, insert, instead of. As you can see here, the before, after, and instead of apply to DML commands. So you can say before insert, after update. Well, essentially you'd say before insert or after update, or delete instead of delete. You can make it very complicated. Rule of thumb, keep it as simple as possible. It's not a good idea to make these things complicated. In my opinion, looking at many large, busy databases over the years, it's not a good idea to use triggers at all if you can possibly avoid it, because it creates too much complexity. It's good from a programming and a prototyping perspective. Long-term scalability is going to be effective badly. Triggers are probably an old idea from relational database technology from many years ago, if not many decades ago. They used to be called database events. In my opinion, it's best to avoid them. But still, they do exist and they do have their uses sometimes. Within a trigger, when you go in, because you're inserting a row, for instance, you're inserting new values, which doesn't apply to referencing. Why? Because when you update, you could be updating existing values, so therefore you have old values that already exist in the row, and new values that will exist in the row after the update occurs if it succeeds. So obviously it doesn't apply to insert, but it does apply to update, and it does apply to delete. Except that with delete, you'll only have old values as opposed to new. So basically what it's allowing you to do is actually compare the value before it's changed with the value after it's changed. It's very useful when you're trying to figure out that you're doing something in a table and you're changing something and the trigger is fired because you're trying to update something and it says, well, maybe you can't update it to that, so you kick out an error or you're going to do something else, perhaps another trigger. This is the danger with triggers, is they can actually snowball and you create lots of triggers that fire other triggers and it goes all over the place and eventually you have a snowball effect across the entire database. Triggers do not contain commit and rollback commands. They do not terminate transactions for obvious reasons. If you say before insert on a table, how can you insert a row inside a trigger into another log table when you haven't actually committed the transaction that caused the trigger to fire in the first place, because it says before insert, because you're going to go to the trigger, you're going to create a log entry, then you're going to go back into the whatever the command was that fired the trigger, and you're going to insert into that table. So both the transactional operations inside the trigger and the thing that caused the trigger to execute in the first place had to be wrapped into the same transaction. You can very quickly end up with a very big, uncontrollable, unscalable mess. Caution using these things. For each row means it applies to for each row applied in some kind of statement such as an update. It could also update many rows at the same time, which means you've got to apply each trigger execution to each update of a table. That gets even more complicated. You get a lot of potential trigger executions. You can also have a when condition, which is basically a filter on a trigger. You only fire the trigger when something occurs. A when condition, a filter. Simple as that. Using the alter trigger command, you can actually enable and disable triggers. Why is this important? Mainly because triggers can get really complicated. They can be used to enforce referential integrity, for instance, which enforces primary and foreign key relationships between tables. What if you want to delete data and get around that primary foreign key restriction? Well, the easy way is just to take the trigger and disable it, remove the data, change it around, and re-enable it again. You can rename a trigger, and you can also compile a trigger. As far as dropping a trigger, it's a simple drop trigger command. Now let's take a quick look at some sample trigger code. So here I have a table called events. It is essentially an event with a date. So I'm going to create this table just for fun. And I'm saying after insert or update of the name on a table called category. Actually, we've got insert or update of name, column or delete on a specific table. For each row that we change, add, delete, we're going to go and insert into event. Basically, it's a log file. Let's see if I can run this. Yes, I do have. I wasn't sure if I actually had a table called category in here. Let's check. I may not. Yes, we do. And does it have the right field names? Yes, we have events and category. Okay, I'm just checking that. Okay, now it's doing strange things to me. Let's get rid of that. So, all this is going to do is simply say, when something like this happens to this table, it creates an event. It's like a log event. So if I go and I enter something into this category table, and I update it, and I delete it, I haven't committed it yet. Note, the events are there. Triggered event on category, triggered event. I could actually pick up the specific events, but I don't want to. And I could go and do a trigger that specifically does an insert, a trigger that specifically works on an update, and a trigger that very specifically works on a delete. So we can go and look at that as well. At this stage, I have not executed a commit command or a rollback to add the triggered values into the events table and make the category table changes. These DDL commands should actually run a commit, because DDL commands do that. A create or replace trigger command is a DDL command. I'm creating separate events for each one. Did I compile them all? I think I only compiled 2 of them. One, category insert, category update. There's no harm doing it twice. Now I'm going to disable the trigger, which is the first one, right? So what I have here is a trigger that does insert, update, and delete. And I went and created 3 triggers that do insert or update or delete separately. We obviously can't have 2. Well, we can. It would essentially add double the data. What are we going to do here? What do we have? As you can see, we did commit those rows. Now we have an insert and update to delete. Now, remember I said that triggers didn't terminate transactions. What happens if I do this? Roll back. I have only the 3 rows from the first trigger. These were not actually stored, the ones from the 3 separate ones. So you've seen triggers in action there. Interesting. So now let's go and search the manuals for the various trigger syntax options: create, alter, delete. Just quickly so we can see where they are and what they look like. An easy method of doing this is to click this thing here and type create trigger. And as you can see, we get the create trigger statement. It doesn't tell me exactly which book it's in. Create trigger. I'm actually in the database PLSQL language reference, and it should give me the create trigger syntax. I can also find this inside the SQL reference language manual. This basically gives me the syntax for the trigger command. There are various things that I haven't covered because they're a little bit too detailed as far as I'm concerned for a course at this level. But as you can see, we have create or replace a trigger with the source code, and the trigger source is in a schema. It could have it does have a name. It can be in a different schema or the same one. Simple DML instead of compound system trigger. So a simple DML trigger is before or after, and with enable, disable for each row when. We also have an instead of trigger, which means instead of delete, insert, update, delete, etc. And we can also look into nested tables, which gets into object programming, which we won't look at this stage because that's much more advanced. We'll look at later on. Here's a compound DML trigger. Let's go back a bit. So note we've got a referencing clause there, right in the middle of the screen. We go down to here, we will see the syntax for the referencing clause. The old column names, the new column names, the parent, etc. It's allowing you to address the 2 states or 2 sets of data as you go into a trigger, for instance, with an update. It's allowing you to access the old data and the new data before it changes and after it changes. And now, what else would I need to look at in the syntax here? Okay, I want to look at system triggers first. System trigger basically is triggered by a system event, a DDL event. Anything DDL, such as a create index command, an alter index command, a create trigger command, the same thing. It's all the same process. It's saying that a system trigger will essentially execute based on the occurrence of a DDL event, such as a create trigger command or an alter index command, and so on and so forth. We can also go back to here and look once again at a compound trigger. A compound DML trigger actually allows you to execute at different points. In other words, as opposed to just an insert, just an update, just a delete, allows you to execute for all 3. We can actually figure this out by going down here and finding the description. Again, a lot of working in these courses is learning how to use the manuals. I'm scrolling down looking for the description of the compound trigger, and it should be down here somewhere. There we go, compound trigger. Go and see compound DML triggers. And as you can see, a compound DML trigger created on a table or additioning view can fire at multiple timing points. Each timing point section has its own executable part and optional exception handling part. In other words, you can have insert, update, and delete. We can see here before the triggering statement runs, after the triggering statement runs, before, after. This is very detailed and complex and will be covered in a later chapter.